Azure Sphere with Sudhanva Huruli.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your team move fast and deliver quality and run your software with confidence in Azure and using everything that the Microsoft ecosystem has to offer. And if you're running a .NET or Azure related user group and would like a speaker, reach out. I love giving those presentations, and there's other MVPs who enjoy it as well. Today on the show, we have Sudhanva Huruli, and he works on the Azure Sphere team. He's also been at Microsoft for over 3 years, working on various teams like the Distributed Systems Platform, Service Fabric, and Kubernetes, among others. So, Sudhanva, welcome to the show. How are you, sir?
I'm great, Jeffrey. Thanks for having me on the show. Thanks for inviting me back. Super excited to talk to you and have a conversation about Azure Sphere today.
Absolutely. And you were last on the show, episode 68, and we were talking about the open application platform, so people can check that out.
That's right. I think the open application model I think we had recorded the show almost a year ago. It's been exciting to see some of the progress that's been made over on that project. I still do check in every once in a while. Actually, gave a talk with Crossplane, who became one of our partners on that project since we spoke on it. And I think the folks at Alibaba have also added a project called Kubevilla to the open application models organization in GitHub. So encourage everyone to check that out, and also the episode to learn more about the project.
Awesome. So you're at a new team now on Azure Sphere. How did you decide to make that transition, and what does that new team do?
So Azure Sphere piqued my interest just because while I was working on the open application model, one of the areas that was interesting to me was the IoT space, the types of workloads that folks are running on the edge. There was a really sweet gig on the Azure Sphere team for the programming model and application model, which is what I was already working on, but on the edge side. So that's kind of what triggered me to make the move to learn more about the IoT space, and it hasn't disappointed yet so far. It's been fantastic. Nice.
Now, Azure Sphere has been around for a few years, and I actually have the first model system on a chip, but there's probably developers out there that either haven't done IoT or any kind of system on a chip, and they not sure what it is. So, can you give us the overview of what version it's on and what you can do with it now, and what you're still working on, what you can't quite do with it but you want to?
Yeah, so there's a lot that goes into Azure Sphere. So the first chip, probably the Azure Sphere chip that you have, Jeff, is the MediaTek chip that we have. So it's called the MT3620. Mm-hmm. And what we end up doing is we partner with silicon manufacturers, so MediaTek, and we just announced one with NXP. And we work with them on a system on a chip that's built with Azure Sphere. So it has Microsoft's Pluton, which actually runs in Xboxes to provide hardware root of trust for your devices. So we secure things from the chip all the way up to the cloud. So we also provide an operating system that allows you to run your Linux workloads based off the Linux kernel. It's tweaked a little bit. And then there's the security service that is managed for you that provides constant updates to your firmware and the OS to make sure your device is secure. And so, if you're thinking about companies or even developers, hobbyists sometimes use this, and you're trying to create IoT devices, so sensor devices, where you want to collect some data and pump it back to the cloud to do heavier computation. The sensor devices, when you connect them to the internet, are open to a lot more attacks, and that's kind of where Azure Sphere with MediaTek and the MT3620, or some of the newer chips that we announced, which, if you look at the spec sheets, are a lot beefier, make a lot more sense.
Okay. And myself included, and people who've checked out the first version, one of the things I noticed was you had to write the code in C. Is that still a singular platform, or are you supporting more platforms? What's the vision and the strategy there?
Yeah, so that's a great question. Since we announced it, we're still working with C, and the primary limitation and in some cases this is good for customers, is that the 3620 chip, the MT3620 that's out on market today, has very limited memory. So both flash and RAM, it's very constricted. What this means is we provide languages like C in that environment, C++, Python are two languages we get a lot of requests for. It would be super hard to pack those on the chip. One thing I will say is on the chip, on the operating system, we do have a version of libc. So we use Muscle, which is a C kind of support for embedded devices. So if someone's really keen on doing it, they could get C++ running on the chip. There's a few POSIX APIs that aren't supported where folks could run into trouble. Languages like Python just too hard to fit on the chip, and that's kind of the reason we don't.
And that's not the vision for these types of chips. We're not writing a full software application that uses this as a general purpose CPU. We're just using this as an adapter for a sensor or a servo or something kind of on the edge of our software. Can you give a few examples that have kind of had some uptick among customers that have adopted it?
Yeah, one of the most common scenarios we see this deployed is what we call this Guardian module. So what this means is customers have, like you mentioned, existing servos or existing motors or HVAC systems, and they want to pull telemetry from those devices to make decisions. And that's where Azure Sphere comes in with the 3620. You can just kind of plug it in, and on one side, it's talking Modbus, TCP, and protocols to pull data from these devices. And on the other side, it's connected to the internet now securely. And it allows you to pull data and send it to the cloud to do a lot of metrics. And in those situations, you don't really need a lot of the perks of a higher level language. That said, though, we've heard that asked frequently, and you brought up the question of vision earlier. And if you look at the SoC that we announced with NXP this week, it's much beefier, a lot more memory, a lot more RAM. In fact, it has an option for expandable storage. And so I think you'll see some, advancements there where we start hearing, supporting some of these higher level languages. And I think one thing that's super interesting is a lot of customers, when we speak to them now, are very interested in running lightweight ML models on the edge. Do a bit of computation crunching on the edge and then send it back to the cloud. So,
well, I can see that. One of the pet projects I'd love to do is to put a little camera, whether it's an Arduino spec camera or something, at the front gate, and then just detect, hey, is something there? And then what is it? If I could detect, oh, this is a deer because we live out in the country, or this is a car, and then not send everything back to the server, but only send it back if it matches something. That'd be great. Yeah,
and that's a great example of when folks might want that higher level language. Doing that in C would be super difficult.
Yeah.
And I think we heard that Python specifically would be fantastic for that because it has the ecosystem of the modules and the libraries that you can just pip install and go to town.
Now, am I speaking out of turn, or is this something that you, even with the beefier chips, do you envision ever having .NET 5 run on it, C#?
You know what? We've heard that a couple times on a beefier chip. And because we're built off the Linux kernel, we'll probably be targeting something like .NET Core if we ever do. we haven't tried it yet, but it's something that definitely interests us. C#, .NET, .NET Core specifically.
Yeah. Okay. Well, let's help the listeners with a full scenario. So the listeners want to learn about shipping software, and this is definitely a unique type of software that you would put on this type of device, and they have some other software system, and like you mentioned in the scenario, we just need some telemetry. We just need some numbers, some data to come streaming back in. Simple scenario. So they've got their DevOps pipeline set up for the regular application and some type of database that's recording all these, but then we need to stream it in. So talk about the architecture of, let's assume that they're already running the other application in Azure. Talk about the architecture. What are the main pieces that have to be up and running and connected to even start writing some code that's going to run on the Azure Sphere?
Yeah, so when you start development on Azure Sphere, the first thing you're going to do is probably interface with the Azure Sphere CLI. You're going to create tenants, similar to AAD tenants. You're going to create a tenant that owns a set of devices. And the Sphere service that I talked about earlier helps deploy your applications to these tenants. So, from your CI/CD pipelines, one of the things we see most frequently is customers have scripts that take an application and talk to the Azure Sphere security service to actually deploy the devices. Now, if you're talking about the full flow for a developer, most often developers will get a dev kit. So the chip that you have is actually a development kit. So it has the system on a chip, and then Seed, who actually helped us build the dev kit, created a dev board. So they attached ADC to it and some LEDs that allows you to do some nice testing.
Cool.
And you would claim that device into your tenant. So you claim devices into your tenant, and then that allows you to build applications. We have a rich ecosystem in Visual Studio. So you open file new Azure Sphere project in Visual Studio, and you can build your C programs there, compile them, target them to your board. And when you're ready, when you're done compiling in Visual Studio, it produces a package, an image package file. And you just deploy that to the Sphere service that deploys them to your devices.
Okay, talk about the Sphere service. What the heck is that?
Yeah, so one of the things that you need in order to have a secure system is the ability to renewably update the firmware on that system. And if you're thinking about IoT devices, one of the last things you want to think about is running some sort of service to keep your devices updated. So what we do is we actually host a service that's running on AKS, Azure's Kubernetes service, that helps you manage your devices. So in a sense, when your devices are claimed by a particular tenant, the Sphere security service is the thing that's orchestrating deployments over the air to all of your devices. So when you deploy an application, at development time, you can plug it in via USB and sideload it. But if you're thinking about devices, on your farm or at your door, you want over-the-air updates to those, and that needs to be done by some service in the cloud, and that's what the Sphere service.
Okay. All right. So, correct me if I'm wrong. The actual chip that is going to run your program is registered with your tenant, with your account, and Microsoft or the service in Azure is actually verifying that only chips that I've authorized are even going to connect and do anything. I think that's part of the security play, right?
That's right. It actually goes beyond that. One of the things that happens when the SoC is fabricated is the idea of the SoC, the system on a chip, is fused into the hardware. And every single day, the Azure Sphere Security Service talks to your device, and there's a certificate that's issued to the device that proves its authentication. So if I have device foo, that device every day talks to the Azure Sphere Security Service and gets a brand new certificate. So the certificate's rolled every day. So you also get a managed certificate that allows you to use for authentication. One of the things that we pride ourselves on is passwordless authentication, because it's not the safest option out there. And by providing the certificate for you, you have a managed cert for auth with Azure IoT services or any other Azure service that you might have.
Okay. So if you have one of these chips out there and it's running, is Wi-Fi the main connectivity, or what are the options?
Yeah, so Wi-Fi on the chip we have today is the primary connectivity option. We also have Ethernet shields. So you can imagine you have your chip, has Wi-Fi support initially, but we've added this Ethernet shield they can attach on top that allows you to get Ethernet connectivity. So those are the two primary connectivity options. And it really depends on the chip and the silicon manufacturer. That's
Sure.
the one with the MediaTek that we have. And if you look at the chip we announced with NXP, the configurations might be different.
And when it connects up, does it connect to multiple places, or does it always connect to the service in Azure?
So there's two parts to this. One is it always has to connect to the service in Azure, and the service in Azure does a few things. First thing, when your device connects, it checks to make sure that the identity of the device hasn't been compromised. So it checks that certificate, and if it's old, it issues a new one. One of the other things that we also do is check the version of the firmware on the device. Every time there's a Linux kernel upgrade or CVEs issued in the public, we pride ourselves on making sure that our firmware is updated to the latest, and we actually push those updates down to every device to make sure that they have the highest security standards. So if some of these devices are on older firmware, we check that to make sure that they have the newest firmware and then issue an update.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
I'm seeing a theme here as well, is that there's so many things that you could do, and maybe you could be responsible for deciding what network protocol. You could be responsible for deciding where to connect to, but it sounds like, just like for example, Azure App Service, if you're willing to accept a lot of constraints, then you could get something working a lot more simply, a lot more quickly, because so much is just automatically done. That's pretty exciting.
That's right. I mean, one of the things that we discovered is that creating secure IoT solutions is very difficult. So providing a platform that gives you all the tools to do that easily, to allow you to focus on, your apps and your monitoring system or your sensor data collection system, whatever that is, what's kind of key for us. And yeah, that is definitely something we pride on. And comparison to the app services is pretty decent. Yep. Okay,
so it's going to power on, I'm guessing, power over Ethernet or a battery or just some type of direct current, right?
Yeah, you have your options. One of the things is when you're connected only via battery, you need to be super power conscious.
Mm-hmm.
Running a full-fledged embedded Linux on a Cortex-A can be a battery drain. In fact, just running a Cortex-A on batteries is challenging. But so we do have some ways for you to optimize battery or power management.
But in the simple case, let's just say that we connect a temperature sensor. With just some type of sensor where, every so many seconds or on a routine, we need to say, okay, what's the number? And that's connected to Wi-Fi. So can you trace us back? How does that number make its way from the sensor all the way up to a custom .NET application that's running in Azure? What are the different hops?
Yeah, so typically the sensor, you can connect it via various peripherals. So depending on the sensor, it'll have some protocol. I'm just going to go with the super simple case of GPIO. So you have general purpose input output pins. And one of the things you can do is connect your sensor to one of these pins. And when your application in Visual Studio, you have your Visual Studio open in front of you, you have the dev kit, you have a breadboard where the temperature sensor is connected to the right pin. In the Visual Studio application, in the you'll see an application manifest. You have to declare explicitly that you want to use a particular GPIO pin, and you would pick the one that your temperature sensor is connected to. Next, you open up a template, a sample project. We actually have a very rich set of samples on GitHub. So you would probably start with one of those. And in front of you, you'll have a C application. And there's two options here. To read the information from that particular sensor, the Azure Sphere team actually provides hand-rolled APIs that make it easy to use peripherals like GPIO. So we have our own SDK with our simple APIs that allows you to read data. So, in C, you could imagine you do GPIO open. You get a file descriptor for that particular pin, and then you can start reading data from it. We also understand that there are customers who are familiar with APIs already in Linux. And this can be a lot harder for some folks, so we also allow folks to do that. You read that data, and then you have a couple options. Most often, we see customers using our Azure IoT Hub. And so you have an IoT Hub instance running in the cloud, but you need an SDK. You need some way to actually talk to that IoT Hub from your Sphere device. So we actually provide the C SDK for IoT as part of the OS. So you don't need to manage it or install it with your app. It's already there. So you can just, in your application, pull in the headers and use the IoT APIs to stream this data to IoT Hub. Now, when it's in IoT Hub, it's really up to you and on how you do it. There's a couple ways you can do it. Some customers use event hubs that are connected to IoT Hub to stream this data to like an Azure Functions or some database. And then it's really up to you. One of the most common things we see folks do is use Azure Functions, where you can run that .NET application based on some trigger. In fact, Event Hubs has a trigger for functions, I think.
Yeah, once it's in the IoT Hub, like the whole world is now open. You can pretty much use whatever your application needs, it sounds like. Yeah,
and at that point, it's really up to you whether you have a PaaS, you have something running on AKS that's getting this data. It's really up to you.
Okay, so the little application that's running on the Azure Sphere chip, that sounds like, what, a dozen lines of code, couple dozen lines of code? Is that about right?
Yep, super small.
Right, so it's a tiny bit. And okay, so we want to store whatever code we have in whatever form we want to store in a Git source control repository. And so can you go for us, what does, you kind of briefly went over it before, but what are the steps to take that code from source and build it and package it and deploy it?
So building from source, you have three options. First, we support Windows and Linux as your development computer, and I'll focus on Windows mainly for the audience here and also for ease of use. You can use Visual Studio to package up your source, so compile and also build the artifact that gets deployed. You can use Visual Studio Code, or you can use our tools via command prompt. And so what you do is you start with this code, you hit the compile button or hit F5 in VS. It produces something called a .image package, which is the thing that gets deployed to Azure Sphere service, and then which gets deployed to the actual devices. If you're thinking about how this fits into your CI/CD pipeline, you have your source code in GitHub. In your DevOps agent, you would probably run some CLI tool. You would run our CLI tool to actually compile this and produce that image package. So once you have the image package, and then, we're assuming you run some tests before this, you probably want to target some devices to deploy this to. And you do this using our CLI. And our CLI has this notion called device groups. So it allows you to group a set of devices that are part of your tenant into a group that you want to target with the deployment. And so if I have, 10 temperature sensors and they're all doing the same thing, which is using this app to pull data and sending it to IoT Hub, you can imagine I put all 10 of those, devices into the temperature sensor device group. And I run a CLI command of, Azure Sphere, and I could get the the exact words wrong here, but deployment target, and then you do the deployment group, and the Sphere security service picks this up and then deploys it to all of those devices. And all of this is done, in your ADO agent that's talking to the Sphere service. So if you're building a CI/CD pipeline, most often you'll be working with the Sphere security service and giving it commands.
Yeah. So it's all command line. So regardless of the build and deploy tool, it's just command line. And if it's only a very small amount of C code, and let's say we're running on a timer and we're sniffing that temperature sensor on a timer, and that's all we're doing, I'm not seeing a whole lot of surface area to worry about automated test suites unless there's more logic. But what's the sense in your team? How do you talk about that, and when do you say, oh no, we need some type of testing framework for the actual code that's running on the device versus covering the testing at a broader level with the larger system?
Yeah, test. One of the things that we think folks should do is test on the device. Even so, let's just walk through the simple app that's pulling data and using the IoT SDK to send data to the hub. We're talking about really small amount of RAM that's available on the chip. In fact, our documented standard today is 256 kilobytes that's available to your application.
Mm-hmm.
And one of the things that could go wrong, and that does go wrong, is your application is getting, out of memory killed very frequently. So if you're using the SDK, let's say you're pulling data from the sensor, for some reason you have intermittent connection, and the IoTC SDK starts queuing up a bunch of messages to send because it doesn't have connectivity. Your device can go bad. So one of the things we do recommend is before you deploy things, have a suite of devices that's running on dev boards, or if you have the capability to put your actual devices as part of a test suite, and target those devices first under various configurations and see what happens to your application, and then deploy it to your actual devices.
That's a good point.
One thing I want to add is when you add devices into a device group, you can choose the channel that they sit on, and the channel dictates what version of the firmware it picks up. So there's two channels we have today: retail, which is the main line, and we have retail eval, which allows you to pick up the preview version. So one of the things we encourage all our customers is have a set of devices on retail eval, so you can test your application on the firmware that's about to be released, make sure nothing's broken. If it is, you can file a support ticket or let us know.
Mm-hmm. Okay, awesome. And is it a safe assumption that if we do have logic in the C code, that any of the C unit testing libraries work just fine in development?
Yep.
Yeah. Okay. All right. Well, that's great. I can see so many situations here where, okay, everyone's been talking about IoT, but really it's, you have a piece of software, that's the brain, but you need to get some type of code out to the edge to interface with the physical world, with sensors, with motors. And there's a little bit of adapter code, but then all this infrastructure to get it to communicate. You guys just provide so much of that infrastructure straight out of the box. That's exciting.
Exactly. You can think of, in the example that we brought up, all the stuff that's provided for you, the service that manages deployments, the developer tools, the chip that manages security, and then lastly, if you're thinking about your OS and the APIs, we provide the OS for you, and we also manage the CSDK for you. So there's really very little code you have to write to get from sensor data to doing some computations with it in the cloud.
Yeah. And even for people who've never written C code in their life, it doesn't seem like it's so scary, because you're not at that level. It might just be one method, or maybe refactoring out 2 or 3 methods. I'm not seeing entire class models being developed and namespaces and all that. It seems like more of the complexity maybe in figuring out the right way to interface with the sensors and motors.
That's probably the hardest part, making sure that you're reading from the right pin, you've set your pin configuration correctly, and then reading the data, going from the dev board to something that's, actually manufactured. But I totally agree with you. the C code itself is fairly small. And the other thing to keep in mind is, depending on what you're doing, there's samples out there that we have on pretty much every scenario. So there's some starter code that you can look at and say, okay, this is probably where I can modify things to work with my code. Not saying C code is easy, but yeah. I think we hear that, and we have the samples out there to help everyone.
Right.
Yeah.
C's been around a long time, and it's not going away. I mean, everything we build is kind of based on top of C.
Yeah, it's sort of the thing that you can always fall back on, the thing that you can count on to always work.
Right. Why do you need 26 letters in the alphabet when you just need the first 3?
Yep.
All right. So I think we probably piqued a lot of people's interest. And so if they are thinking, oh, shoot, let me play around with this. Let me see if I can get something going. Maybe I've done a little bit of Raspberry Pi or a little bit of Arduino, and they have a few things in their electronics kit. What should be their next steps for testing out the Azure Sphere? Where can they get it?
Yeah. The best way is to go to azuresphere.com. Lead you to our documentation page, which walks you through how to get your hands on a developer kit, order it from Seed's website. And as I mentioned, Seed's our hardware partner that builds our dev kits for us. Once you get your hands on a dev kit, super easy to get started. We have a quick start that takes about 10 minutes to from plugging your device in to getting the Hello World deployed on it. And that's my recommendation. Go to azuresphere.com, documentation page, get your hands on a dev kit, and then provide us feedback. We monitor Stack Overflow and all those places.
Awesome. Well, thanks so much for coming on the show and giving us the latest on what's going on with Azure Sphere. Certainly a lot since the big launch at a couple of Ignite conferences ago. So yeah, you've been moving.
Yeah, thanks, Jeffrey. Thanks for having me on the show again. Always a pleasure.
Awesome. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.